So we've got economics and policy, batteries, solar panels, and wave power. And I want to come straight to you to start. Wave power it's still in early stages, right? But give us a sense of the potential that wave power has around the planet overall.
So according to the World Energy Council, wave energy can actually produce twice the amount of electricity that the world produces now. 2/3 of the world population are currently living on the coastline. With this kind of population distribution, obviously the need for wave energy is inevitable. And in terms of the fact that it's only in its starting point, I think that there are some companies that are already more advanced towards commercialization. For example, EcoWave Power, we already built the first commercial-scale grid-connected power station in Gibraltar a year ago. And currently, we have a project pipeline of 130 megawatts, which we're starting to execute next year.
Okay. And what are the big challenges for wave power?
Bureaucracy is a huge challenge because every time you come up with a new technology, nobody understands it. So nobody knows whose responsibility. For example, if I approach a port, we install our technology on breakwaters. So most of the breakwaters owners are ports. So you come to the port, you say, I want to install floaters on your breakwater to make you clean electricity. So then they don't know where do they have to go to ask for approval. Is it the municipality? Is it some heritage site because the breakwater can be 100 years old? Is it the planning committee? Like they send you to many, many different places until they find out what type of approval you need. So I think if the bureaucracy would ease up on this type of technology and governments would set more clear policies, not only say we support renewables, but actually learn and kind of make a structured path for renewables, then it would make it easier.
Yeah. Christoph, is that something that you see across renewables, this problem of there not really being good policy frameworks?
Yeah, so I mean, many new technologies need a good alignment of several decision makers among policy makers to start with. And then we need a relatively rapid evolution of the technology frameworks, sorry, the policy frameworks, so that we don't go into windfall profit. So this balance is something which is relatively complex to do over time as well.
Right. And so that's the sort of building these technologies out in the real world. But Don and Sam, you are both researchers, batteries and solar panels. Don, tell us a little bit about what you're doing at your lab at MIT.
So at MIT, I've been working on batteries for stationary storage, not for automobiles, not for handheld devices. And the big objective is to make something that is economically viable. And so I've cut out on a path that is unconventional, and instead of having solid electrodes soaking in water or something like that, I've gone to an all-liquid system with liquid metals, molten salt, and as Ina said, it's different. People are puzzled. They want you to prove that it will work forever until they were willing to make any kind of a commitment to it. So it's a really, really steep hill to climb.
Yeah. So working on these kind of newer designs, what do you feel about the current huge boom in lithium being driven by Tesla and all these just huge numbers of, what is it, 18560? What's that battery?
18650.
Yeah, 18650. What do you make of that from your position?
Well, I think it's good and it's bad. I'm happy to see that there's a big push to electrification of vehicles. However, the menace of oncoming low-cost lithium-ion batteries and the presumption that they can operate in stationary storage is having a harmful effect on innovation, because people are saying, well, lithium-ion is here, we don't have to take chances. So it gives them some comfort in avoiding any kind of risk.
Yeah. Sam, does that sound familiar to you, this idea that there's an established technology, and solar panels are great, so we don't need to do anything else? Tell us a little bit about what you're working on and where you see the same thing.
Yeah, so I suppose solar, the two key challenges are, it is still very expensive, but it's come down a lot in price, which is exciting. But there's still a long way to go to really make it much cheaper than other electric sources. And the other is how fast we can actually make enough panels to really have a big penetration of solar. With the existing technology, crystalline silicon, which we see on our roof today, It's unclear if we'll be able to do that fast enough. The capex involved in building a silicon factory, a gigafactory, is a lot. So it's unclear if we can build factories fast enough to really scale up solar. So a lot of what I do is working on new emerging technologies, that particularly these perovskites, that really have the potential to be produced roll to roll. And you could really, a $100 million perovskite factory could do the job of a $1 billion silicon gigafactory.
Yeah.
And that's really where, particularly the scalability of solar, we really need these new technologies.
Yeah. One of the things I find fascinating about renewables is that they're taking this thing that's existed for, at least 100 years, which is the electricity grid, which is traditionally built around this big centralized power plant. And I'd like to hear from each of you, from your own angle, about how what you're doing changes that, and what the grid needs to do to adopt your technology or your way of thinking about it. And maybe, Ian, if you want to.
I think first of all, again, most of the grids, they have substations, and these substations are meant to receive additional electricity sources. So I don't think that the development of renewables is something that prevents it. I think, first of all, probably we need to motivate somehow the electric company and the electric utilities to connect renewable energy to the grid, because actually for them it's just like, I see the Israeli electric company, for them to connect somebody to the grid is just a headache. They don't receive extra money, they don't receive extra hours, they just need to go and take care of something additional, which they don't like. So we definitely need to motivate them. Other than that, I think it's important to adopt many renewable energies to go into the same substation, because what happens, like let's assume solar energy, in the morning you can have 50 megawatts and in the night 0. So this kind of big blow to the grid is something that is very negative for the grid. It doesn't like to go from 0 to 50. So what we need to do is to make sure that we combine both wave, wind, tidal, solar, all the types of electricity. So when there's wind, they get some sort of electricity from it. When there's wind and wave and solar, all of them produce together. And then the grid would be much more, treated much more gently than going from 0 to a big amount.
Yeah. I mean, that wind, wave, and solar picture, it sounds like the right thing, a mix. There's no one silver bullet renewable technology that's going to solve everything. But how do you actually do that, Christoph? There are challenges in plugging all those varieties of sources into the grid with their different variability patterns. And, what challenges do we face when we try and do that?
So to me, I think my neighbor has part of the answer. We will have technologies that are going down in cost very rapidly, which are competitive when there is wind or when there is sun or when there will be enough waves, but not all the time. And if we harvest that, we will need to find a way to store it. So I think, integrating some storage solution at different levels, so at the level of the consumers when we have decentralized energy, but also at the grid level is something which is important. And that's why I'm a strong believer in static batteries. I think we will need those, and I agree with you that lithium-ion is probably not the right solution for static batteries. It may not be enough. We may need some other storage solution, transforming huge amounts of power into some kind of fuel, which can be hydrogen, which can be gas, which can be liquid fuel. But we will need probably something more, because if we have on the same place lots of renewable in feed, when there will be lots of wind or lots of waves or lots of sun, the network as they are today, they will burn.
Yeah. Why is it done? Why can't we just plug a Tesla Powerwall into every house in suburbia and run some clever software across the whole thing and job done? Why can't we do that?
Well, the lithium-ion battery was invented to power handheld devices, and it does it very well. When you go to these large capacity batteries, they have thousands of cells in them in close proximity, and lithium-ion does not take well to handling high currents. The high currents will cause a temperature rise, which can pose a threat in terms of safety, and so on. So it's what works at the scale of your mobile phone doesn't work at the scale of, say, a 10-meter shipping container. So it's not the same. And then also the rate of current, when you talk about large swings in power and we want to level those swings by putting them into batteries, there are severe limits on how much current you can put across a lithium-ion battery without, again, causing damage to the electrodes or causing the electrolyte to burst into flame. So that means that, you know, we need to balance, and we've got to use every trick available to us to capture that energy. Either that, or we just don't take the energy. If supply exceeds demand, I mean, there are wind turbines in Alaska that 90% of the time are not turning because the supply exceeds the demand, so they change the position of the blade and the wind blows and nothing turns. It's really a challenge.
Yeah. You know, how does wave power fit into? I think the conversation is somewhat dominated by wind and solar and their different intermittency profiles. Where does wave power fit into that? You know, what is its profile like?
What do you mean? What is its
Well,
profile?
like, is it relatively consistent? Does it tend to have a daily cycle? Does it have a monthly cycle?
So what's good in wave energy actually it's the fact that it is consistent. You can predict it at least 3 days in advance. So if there's an upcoming storm or anything, you know it in advance, which is a good thing. Other than that, for example, before we go build a power station in any place in the world, we use a special company that gives you satellite data of all the waves. You can get all the waves of every location up to 20 years backwards, so which is amazing because, for example, in wind energy, you have to spend few millions dollars just to put equipment to measure throughout the year the wind velocity and everything, all the wind characteristics, and check the influence on the bird migrations and everything like that. In wave energy, you can just buy the data. It's available for every locations. Moreover, ports and the locations that we install in obviously already collect this data to give information for the fishermen, for the ships that are coming, about the upcoming storm or anything that they should be careful about. So in terms of the wave, like the ability to forecast the wave, we can forecast them in a very good manner. In addition, also in terms of availability, obviously it depends in which place in the world you are. Location like Chile, Scotland, Australia, locations that are very open to the sea, you can get 90% of your electricity only from wave energy, which is amazing. It's a great availability, which some other sources, unfortunately, cannot supply. In other locations, you can reach a lower percentage, let's say 1/3 of the electricity needs, but for a renewable energy source, even 1/3 is considered a lot.
Yeah. There's been quite a few fairly high-profile failures in wave power companies. I'm thinking about Palamas and Ocean Power. Is Ocean Power still around? Sort of, kind of.
It made the final raise in the Nasdaq, they ask help from the population.
But why do those companies keep? I mean, they clearly get a lot of press because it's kind of a cool idea. But why do they keep? What problem do they keep running into?
First of all, I think wave energy as a whole has negative reputation based on 4 different issues. The first one is the price of the systems. 99% of our competitors decided to go offshore. Offshore means 4 or 5 kilometers into the sea. When you're building so far, you need ships, you need divers to install it, you need underwater cables, underwater electricity transmission. It can reach to billions of dollars in construction of a power station that can supply electricity for, 1,000 households. It doesn't make sense. You would never receive return on investment, so obviously that's not good. So that's one problem, the price. The second problem is reliability. Pelamis, for example, one of their machines broke down after 3 days of operation on the coast of Portugal. Obviously, that wasn't a celebration for wave energy. Everybody invested hundreds of millions, and it just, crashed. So the reliability factor is something that people find scary. Like, for example, the sun, it wouldn't suddenly stop shining. But with wave energy, there are storms, especially in the offshore. You can get even waves of 20 meters. Obviously, you can't save stationary equipment. No ship in its right mind would go inside the storm to save the equipment. They would more likely to save their own lives. So the reliability was a problem, all the breakages. Other than that, environmentalists, instead of supporting wave energy, were objecting it because it's new presence on the ocean floor. So the fish get tangled in the lines and all that. And the fourth problem is that no insurance company agreed to insure wave energy. When you don't have insurance, let's say I'm offering you the best house in the world, but you know that once a year you have an earthquake and no insurance company would pay, you wouldn't take it, even for free. It was too bad for the furniture that you put there. That would be ruined on a yearly basis. So that's something that our company actually try to fix and is fixing is the bad reputation. Is we came up with a product that is only to a niche market. It's existent breakwaters and structures, no ships, no divers. We just moor it with cranes. Only 10% of the system is located in the ocean, in the sea, whereas 90% is on land, so you can use a lot of off-the-shelf equipment. Insurance company gave us 100% insurance, including against storm. The environmentalists are happy because it's man-made structure. They hate them. So we say, okay, we turn something that you hate into something that actually makes electricity. So I think by going by that simple, keep it easy and simple approach, like the KISS approach, is something that would give wave energy an additional boost and would make create the commercialization. I think that all the companies that went to spend hundreds of billions of dollars to develop offshore difficult technologies should maybe make a recalculation and kind of go into a simpler way. Although their efforts haven't been unnoticed, we definitely learn a lot from them, and we appreciate the hard work that they did, but we need to simplify it.
Well, very nice.
Thank you.
Sam, it clearly matters how you deploy these technologies. And, you know, the way what Ines just described, it rings a lot of bells for lots of different renewable technologies. Are the kind of cells that you're working on in Cambridge, are they going to have similar kinds of possibilities in terms of where and how you deploy them in a different way from current, giant solar fields in the middle of the desert?
Well, I suppose one of the things that we can do that, in most silicon panels you see are bulky and heavy. One of the things that something you can print roll-to-roll could do is to produce a very lightweight panel that you could, or flexible panel that you could roll out like a tarp. And actually there's an estimate of about 40% of commercial rooftops in the US can't actually take the weight of silicon solar panels. So there's a huge market there and surface area that solar can't actually currently access. So I think some of these new applications and also in the developing world, of course, there's lots of roofs that can't take the weight of crystalline silicon panels. So I think there is a paradigm shift in deployment. Also potentially lowering a lot of the costs of transport. If you have a roll of these sheets, you could transport them a lot easier, a lot more cheaply. Also into the developing world where it's harder to get these panels into.
Yeah. And how close are we to actually commercial? I mean, I think there have been a couple already, but there are huge numbers of solar panels being installed all over the planet. But how close are we to this sort of new kind of material being rolled out and used?
Yeah, so these perovskites, actually, the first application is going to be putting them on top of silicon panels. Okay. So on top of the existing technology and actually boosting what we have today. So there's actually a company, Oxford Photovoltaics, doing that, and they're looking to have a product at the end of next year. So it's very, very soon. And if you think about, the first activities in these perovskites really started in 2012. That's 5 to 6 years to have a product. That's very, very quick. Some of these flexible roll-to-roll applications are probably still another 5 years on top of that away.
How much extra do you get when you put a layer of perovskite on top of silicon?
What efficiency can you get? So silicon is now at 26%. The limit for any single panel is about 30%. And that's a theoretical limit. It's probably going to be a bit lower than that. But with the perovskite booster, you can get just over 30%.
Okay, so that's quite a big deal when you've already spent the money to buy the land and get all that stuff sorted out. You can just get this free extra.
Exactly. Yeah. Every little bit of efficiency gain just brings down the overall cost of the system.
Yeah.
So
So Don, we're going to have big power plants out at sea generating large amounts of power, more and more solar power. Where do you envision your kinds of batteries being deployed? Like, what's the topology of your deployment network look like?
Well, they could go pretty much anywhere. They could go at the substation, but they can also go right where the demand center is. So, for example, in London, you could put them in the basements of skyscrapers, and during the wee hours of the morning when the demand is low, you could take electricity off the conventional grid and store it, and then in the middle of the day pull it out of the basement. The individual homeowner, of course, would benefit from having storage in the home connected to whether it's wind or solar. So there are many different locations where this can be deployed. And we've never thought about it because it was never an option. It doesn't have to be, well, if you've got a gigantic generator facility well, then you need to put next to that a gigantic battery. You can put the batteries closest to their consumption point.
Right. Although as we were discussing backstage, you do have scenarios with like offshore wind farms where they are creating so much power at night that the demand isn't even there to put it on the grid. So there might be some scenarios where you would need to catch some energy closer to its source. Or is that right? Am I thinking about that right?
Well, if you're producing energy that you don't need, there's only two options. One is either you find a way to switch off that generator, in other words, change the position of the blades so that they stop spinning, or you bring it to shore and you have to put it through some kind of a load. Otherwise, when you plug in your device, you're expecting 220 volts, 50 hertz. Can you imagine if every time, and if the supply exceeds the demand, it could go to 250, 260 volts. Could go up to 55 hertz. You plug that in and you'll blow your device irreparably. You'll blow your devices up. Can you imagine if every time you went to plug in a device, the question you got to ask yourself is, do you feel lucky? Do you?
Not good.
Not good.
Christoph, did you want to come in on that?
Yeah, no, I think when you have really gigantic production, we will need some load, which may be something else than batteries. Because, I mean, we will also need, if we want to really make the full energy transition, we will need also some kind of fuel which is generated by renewables. And so is it power to gas, power to liquid, whatever, I don't know, but we will need that close to the gigantic wind farms, offshore wind farms, or the like. I think the use of batteries closer to customers or at the grid level is also important. We will need both. It's not either or. We will need both for sure. I think it raises a question of, do we go for a system which will be individually optimized by the people who will be able to invest first in those new technologies, or do we want to are we going to more towards a collective optimum? And that's a relatively complex question. I mean, it's a question of public policy. It's even a societal question. It's faster to go for individual optimum. If I have the means today, I can invest already in solar panels and my static batteries and have a business case for that in some regions of the world already today. I could even consider disconnecting from the grid and stopping paying for the network. The payback will be long, so I need to be able to carry this upfront investment and to invest in that. But then at one point, the system will not be optimized as a whole. So that's really a question of, do we go to individual optimum faster or some kind of collective optimization where we are able to pool the flexibility of different customers to allow more and more renewable in-feed into the system.
What does the collective, I think the individual vision is quite clear. You know, you lay solar panels all over your house and put batteries in your basement, and as much, you know, you add as much generation locally as possible. What does the collective approach look like? What do you mean by that?
So the collective approach would be, it has to be something relatively simple where the flexibility of even small customers, so the ability to change a bit the target temperature on a heating or cooling system, the ability to interrupt some equipment is harvested in a way through a relatively cheap and simple transaction chain, probably using blockchains or the like, where people who have batteries on their premises can also valorize that, and it's used somewhere else. Rather than using my own flexibility for myself as a customer, it's used at the grid level.
We've never really had to have these conversations in the energy world before, have we? Sort of real consumer politics conversations. I mean, not so much as we do now, because consumers are about to get both the means of storage and generation into their own hands. So is that a problem? Is that difficult to deal with?
I think the technology is not there. I'm convinced it will be there. I mean, we had already some systems which were going in this direction. I mean, night tariffs and day tariffs were a way for every customer to, in a way, pool their demand at the right time for the system. So it was already there in, I mean, 20, 40 years ago. What we are talking now is harvesting much smaller sources of flexibilities, much faster cycles. I think it's possible. The question is, can it be, do we have energy systems which are agile enough? Do we have distribution system operators which are rapid enough to implement those technologies to go to some kind of collective optimization rather than individual optimization by the ones who can invest?
Got it. Let's talk about the sort of the bad boys of the energy world for a little bit, the fossil fuels and nuclear. I mean, there's a lot of positive momentum for all of the technologies we've been talking about. But when you sort of get down to it, most people seem to agree that I've talked to that we're going to need fossil fuels and, depending on who you talk to, nuclear for a very, a really long time to come. How do you all think about the role that fossil fuels have to play? Where do you see it being needed the longest and most critically?
Well, I think in high power applications. I mean, I do not see in any future the notion that you're going to put an Airbus 380 into the sky on electric power.
Yeah.
I just don't see it. So you're going to have to reserve fossil fuel for the high power application. Now, granted, there may be a situation in which we can generate all of that fossil fuel out of biofuels and make them carbon neutral, but certainly that's something that we can't walk away from. But I have another thought, because let's think. And so the issue is not the fossil fuel, it's the emission of CO2. So why aren't we asking to invent a process that destroys the CO2 so that you burn the fossil fuel, you get the thermal value from the fossil fuel, but instead of sending CO2 up, something else happens. Granted, you have to put energy in order to destroy the CO2, but that energy could come from renewables. So it could be free, and or essentially zero marginal cost. So why aren't we doing that? Because the alternative, we can't. It's sort of like when I was in college. That right around that time, it became unfashionable to be smoking. Before then, there were cigarette ashtrays at every desk, every seat in an auditorium in the university. And then it became unfashionable. So the joke was, you can smoke, you just can't exhale. So the same thing with the fossil fuel. You can burn it, you just can't emit.
Right.
So
right.
let's invent.
Zero carbon is what we want, not necessarily no fossil fuels or no any particular thing. Sam, did you want to say anything on that?
Yeah, I mean, certainly aviation is something like solar just can't provide.
Yeah.
I mean, I think I had a point. I've now forgotten what I was going to say.
That's okay.
I was just thinking about what Don was saying. I mean, that would be if we can, use this excess energy we're producing from renewables to convert CO2 to something else. That would be fantastic.
Yeah.
If anyone has ideas about that, or I'm sure there's some work being done on that,
Yeah.
it would be very good.
Yeah.
I mean,
I'm sure I'll think of my point in a sec.
Given the quantity of renewable resources we have on this planet, we could, I think, go for a completely renewable energy system, even for heavy transport with hydrogen or whatever. The big question is, we don't have the time to wait for those technologies to be there. If you look at all the climate scientists' consensus about the speed at which we need to reduce our emissions, I mean, we cannot wait for another 2 decades before we start to really reduce the emissions on this planet. So we need to go fast with what we have, and the concern I have is that in the short term, fossil fuels are there, and especially in emerging markets. I mean, most of us are from very rich countries. We have the resources to invest in the energy transition. And if you see the progresses that have been done in the rich countries in energy transition, I mean, it's impressive. We have lots on this planet of countries where governments are struggling to ensure good health care, nutrition for all the population. The burden of energy transition for them, going out of fossil fuels and replacing by renewable, is huge. And especially it's a huge upfront investment. Even if it pays back in time, it's a huge upfront investment. So the question for me of fossil fuel is really linked to the poorest countries on this planet.
So we can't wait around for fancy CO2 to fuel technology to really take off. We need to do as much as we can, as fast as we can. Ina, how do you look at this problem? Where do you try to sell your product? Like, do you have target markets, or is it just anywhere with a coastline?
About that problem that you talked before, I just wanted to add that I think the main problem of renewables is the fact that renewables are perceived by the whole population as something great. Everybody wants it, but it's not perceived as reliable. Fuel energy, on the other hand, is bad. It kills you. It kills the next generations. But it is reliable. So people are preferring to stick with something that they know and they're familiar. So I think that as soon as renewable energy, which will prove their reliability, which means like there would be an appropriate mix of technologies that could provide 90 or even 100% of the needs, then the move of the government, of the electric companies, of everybody would be faster. And what was about wave energy? Sorry.
Oh, well, I was just wondering whether your product is suitable for developing markets. Was basically what I was wondering. Like, I wonder where wave power fits in there, because it's traditionally quite expensive, but it sounds like yours is less expensive. So I was just wondering.
So our at the moment is $1 million per 1 megawatt, which is equivalent to solar, which is cheaper than wind. So we don't expect the developing countries to pay for it. We usually fund the power stations ourselves. What happened is we built a power station in a BOT, build, own, transfer kind of mode. Which means that we own it for 25 years, we invest in it, fully invest 100% of the construction cost, and the only commitment that the government give us is basically to buy the electricity from us at a predetermined feed-in tariff, so we could return the money to our investors. Yeah. So it is very suitable to developing countries, Ghana, Kenya, Namibia, South Africa, all these countries that suffer from 70% of Africa doesn't have access to electricity at all. So to cover part of their coastlines with wave energy could be the solution for them.
Yeah. Well, that brings us on to a really interesting question, which is that one of the big differences with all renewable power sources is that there's no fuel, and there's no fuel price to go up and down. And what this means is that all the cost is in an installation, right? I mean, the large majority of it. Do we need different kinds of energy markets even to start pricing these things in a different way? I've heard stories about energy being priced in the same way as broadband, that you just pay for access at a certain tier, and it's a flat rate for everybody, which is going to be a very weird world when we're all used to paying, for how much we use our washing machines. Is this something you've looked at, Christoph?
Yeah, I mean, again, in a world where we would be able to optimize a bit collectively, we would need some kind of flat fee like you are describing. Or at least a fee for capacity, or pay for flexibility rather than the commodity. It's true that we will need to make a massive transition in our market design. Today, most of the power markets are by electrons, so by kilowatt hour. We invested in a lot of wind farms or solar panels with feed-in tariffs where we guarantee some return for these investments. However, the day they go out of the protection of those feed-in tariffs, and that's coming relatively fast now, that's arriving fast. I mean, they cannot be remunerated in an energy-only market. I mean, if there is a lot of wind or a lot of sun, the market will be zero. So indeed, we need to change. The transition will be hyper complex for society, and I think it may be, unfortunately, something that triggers more individual optimization versus a more system-based optimization. There is a huge challenge for our authorities, I think.
Is that a call for regulation?
In fact, yes.
Good.
In fact, yes. But it's smart regulation, it's smart and agile regulation.
Yeah.
And actually, I mean, I think energy has to be regulated. I mean, energy is a primary good, it's a vital good. Yeah. It has to be regulated. The point is that we have had regulations which were not super smart because trying to do a bit of everything rather than making clean choices. we had a time where we were subsidizing lots, solar panels like hell in very unsunny countries, where in fact we should not install solar panels in unsunny countries before they have gone down the experience curve. And it's more in sunny countries that we should do that. So there was a bit of carpet bombing of policies. Plus there is a lot of the movement of regulation is relatively slow, sometimes without a clear big picture, except I think in China, where I think there is a much more clearer view on the long-term system they go to.
Yeah.
But in a growing system, it's easier.
Is there anything batteries can do to help with this pricing problem, Don? Because I mean, or even just a more broad question, how are people going to be paid to offer their battery capacity to the grid? How is it going to work?
That's going to come out of how the markets are established. There are some people that talk about installing excess capacity in their homes and then being in a position to sell to their neighbors. So again, this is uncharted waters, and depending on what the pricing turns out to be is going to dictate how people behave. So, if you put the regulations in place, if you put pricing policies in place, you'll see certain responses. But people need to know what they are, and they have to be in place for a long time. Otherwise, people make plans, and then the policies change, and it leads to it'll actually have a quenching effect, because then everybody else who is thinking about adopting something greener is going to say, I don't want to get burned like my neighbor. So it's really uncharted waters.
How do you think that particularly California is the one I know best, is sort of making some steps to, incentivize the building of a lot of storage, including like huge pumped air storage in caverns and things like that. Do you think that, do you know of any sort of regulatory regimes that are doing well or badly? Would you point to any good examples of how to do this?
I think some of those are ill-advised. I think they have the best of intentions. I think the polite term of art is a demonstration facility. Okay? But if you take a look at how much those things cost, the numbers are absolutely staggering.
Yeah.
But I don't want to be seen as saying, look, we shouldn't do this. But we really need things to get out there that are economically valuable on their own merits. And that involves inventing to a low price point and then having market signals that reward smart moves.
Yeah. Is there a regulatory angle to solar panel production that you're aware of, Sam? Like, I understand most of it's happening in China at this point, but is that a problem? Are there ways to make that a little better for everyone?
Yeah, a lot of the production is done in China at the moment. The price is coming down quite significantly from that. I suppose, just in general, one of the problems with solar is that a panel will last 30 years, and that's great on one hand, but people are reluctant to commit to buying that. And a lot of people maybe haven't bought solar because they might think there's another technology coming around the corner in 5 years' time that means they shouldn't buy it now. One potential way around that is sort of a subscription model, like this broadband type approach.
Yeah.
There is some precedent for that. Solar City in the US, for example, has a subscription-based solar panel type system. Ideally, a system would be such that you get the new technology as it comes out. So that sort of thing, to incentivize, I suppose, people to deploy solar and to put it on their roof, that sort of thing would help.
Yeah. We're getting towards the end, and I want to talk about like the future and what you all think it should look like, what you'd like it to look like. One vision we were talking about back there was this idea that you have huge offshore wind farms, and there's so much free energy streaming off these things that it actually incentivizes the creation of new kinds of industry sort of at the tap. But what does a good energy future look like from your point of view,
We would like, obviously, to see a lot of wave
Wave
energy
power for everyone.
stations everywhere. At least, obviously, not on Prime Beach, not in Miami Beach, but on all the breakwaters that are not being used. I think there's hundreds and thousands of kilometers of neglected breakwaters that nobody does anything from, so we can definitely provide significant amount of the world electricity only by using that. I think we see the way to go there is really seeing policies clear and very understandable pathways for renewables, how to go there. Because when you want to erect a coal power station or even an oil drilling rig, you know exactly what you have to do. That's not the case with renewables, so it's very difficult for us to build a lot, even if we build with our own money, when the process is not really clear of how to do it. And I think that's the main obstacle at the moment for renewables. Maybe also, as they said, the accumulation of the electricity, because a lot of the electricity is being produced in times that the population doesn't necessarily need it. The same like with wind, it's mostly produced early at night, early in the morning or late at night. So that's when the population either sleeps or didn't wake up yet. So that's not so good. But I don't think that you can say that you can just shut off the turbines like they do in some places, because there's private investors and banks behind these turbines. They want their money back. They don't care if you're using the electricity. Everything that it produces, they want to be paid for. So I think there needs to be some solution. How do we use the electricity, but without damaging the investors that are actually investing in it? Governments are not investing too much. So there's a whole separate group that we need to protect. So I think somehow there should be a solution somewhere in the middle, between the investors, the governments, and the entrepreneurs. There should be like an agreement on how to work.
Sure. A future where the investors get their money back. No.
Listen, nobody invests today
No,
without asking
it's
what's
very
the
important.
why.
It's very important. Sam, what about you? What is the solar? Are we talking carpeted solar panels everywhere? Solar panels on our shoes and our cars and just every?
That's the dream. That's the dream.
That's the dream.
I mean, it really is storage, which is the crucial thing. I mean, we could have 100% solar, it'd be fantastic, but just at the moment the grid would not allow it. In fact, beyond 30% at the moment, it now gets more expensive to install more solar.
Yeah.
So really, it's the storage, the batteries, whether it's converting, storage in batteries or whether it's in a fuel. That's really, I think, one of the key breakthroughs that needs to come through. And then it changes how we think about energy. We really have it very cheap, very accessible, not just in developed world, but in developing world. And it really would very quickly change, a lot of people's lives.
Mm. Don, is it going to happen? Are we going to get these sort of huge, big storage systems? Are you spinning out your stuff from MIT?
Yes, but if we really want to see things that go the whole distance, if we really want to see things have a huge impact, I'm afraid we're just not making enough of investment in the research for radical innovation. To get back to your earlier question, this is one of the big negatives of the pervasiveness of lithium-ion. I think people have really stopped working on large-scale stationary storage because they think that, well, Powerwall, that's it. But if you take a look at the rate at which lithium-ion batteries lose their storage capacity, that's just not acceptable. So, but meanwhile, I mean, I don't know the situation here, but in the United States, large-scale funding of radical innovation in energy research is not going forward.
No, ARPA-E is being gutted. Have you ever talked to Elon about this? I'm sure he'd listen.
I have not.
No. What do you think, Christoph? Sum it up for us.
So, I mean, on the one hand, I'm relatively pessimistic because of climate.
I should have gone the other way around here.
For the climate, the problem is that the climate challenge that we have requires global, regulatory-led action very rapidly with huge amounts of investments. They will pay back in time, but I mean, it's huge amounts of money. And these amounts of money have to be spent for 2/3 of them in emerging markets. And so that's, I mean, I think it's a challenge. I don't see how we'll address that one. And I'm relatively anxious with that. On the other hand, I strongly believe in mankind ingenuity. And I think technologies will get us through in the end. The transition might be relatively difficult, but technology will get us through in the end. Okay, you can dream of a system where most of the small energy usage is purely renewable, with batteries managing the loads and demand response system managing the load, and the heavy, more heavy transport, for example, is done through fuels which have been manufactured with the excess energy from large-scale renewable systems. That can be a long-term view. There is also an important element. I mean, we'll get into the system where these new technologies will allow 1 billion people in this planet to have access to energy while they don't have today. So that's also part of the positive things I see with these new technologies.
Yeah. So it's going to be a hard road, but we're going to get there. All right. It only remains to say thank you all very much for a really fascinating discussion. We're a few minutes over, but thanks to the audience for listening, and please join me in saying thank you to our speakers.
Thank you.